What up, everybody? Welcome to Master the NEC's podcast, where we talk about the National Electrical Code, we talk about all things electrical, and we provide it for you in a podcast format so you don't have to see my ugly mug on video. Now, we do have a lot of those videos in case you love looking at my ugly mug. Then you just need to go over to masterthenec.com, and on that website you'll see all the videos we have. But don't forget, you can also go to our YouTube channel. Just go to YouTube, type in Master space THE for the space NEC, and so it's Master the NEC. Do a search on it, you'll see all of our videos. Make sure you subscribe to those videos. If there's other videos you'd like to see us do, please feel free to email us at info at masterthenec.com. We're more than happy to do additional videos for you. So let's talk about today's podcast. So I've had a request to do a actual podcast on Article 300.22. Now, I think 300.22 is dealing with ducts, wiring inside of ducts, used for air handling, fabricated ducts for environmental air, other spaces use environmental air, all that kind of stuff. So I figured I'd do that today on this episode. But what I also wanted to go on and talk about is 300.21 to kind of just capture that as well. And that's about the spread of fire or products of combustion. Obviously, when we penetrate any fire-rated wall, floor, ceiling, or in any hollow space or vertical shaft or whatever, we have to be real careful as electricians that we're not causing any spread of fire potential through these rated assemblies, or the products of combustion can be carried out through the system and cause other problems. So we have to realize that. So anytime we penetrate with our wire or what have you, a fire-rated assembly or penetrating floors or ceilings, we usually have to use a fire-rated detail, and we have to maintain the rating, and we have to make sure that we're maintaining the integrity of that rated assembly. And we're installing in those hollow spaces, we need to make sure that we maintain the rating of that hollow space and that we don't incorporate anything in it that could cause the spread of fire through that space. And that's what we're going to talk about in 300.22 A, B, and C. We're going to talk about the different wiring methods that can be utilized in these spaces. But I thought it was important to cover the basic concepts of 300.21, so I'll read that to you now. And 300.21 is dealing with spread of fire or products of combustion. Now it says, electrical installations in hollow spaces, vertical shafts, and ventilation or air handling ducts shall be made so that the possible spread of fire or products of combustion will not be substantially increased. Okay, there might be an application where you get a fire and you're going to have some combustion go through the products of it, smoke and what have you. But that's not, we don't need to increase that or substantially increase that application by wrongly penetrating these rated assemblies or doing something that's not following the proper UL fire rated detail and things like that. So it's real important. A lot of building officials and plans examiners look for all that on a regular basis, looking for the type of penetrations. The blueprints will come in. They'll have a fire resistance directories detail that came from UL. We used to call those the orange books, and you'll have those details, and you'll look in there, and the engineer will specify which detail corresponds with the type of wiring method or raceway that's penetrating that fire rated assembly or detail or floor. So that's pretty common. The penetrations that are into or through fire resistant rated walls, partitions, floors, or ceilings shall be fire stopped using approved methods to maintain the fire resistance rating. Now, I'm not sure I like the term approved on that, because again, approved being subject to the AHJ's approval. There are listed products, and I guess there's probably products that aren't listed, but and I'm not on that side of the industry, so I just look for, as a plans examiner in the past, I look for a fire resistant rated detail, and that detail will tell me how they're supposed to do it, and how they're supposed to seal that up so that they maintain the rating of that assembly. In other words, we don't lose any ratings. Okay. Now, the informational note that's provided in 300.21, and again, whether you're in the 2011, 2014, or 2017, nothing changed when it comes to 300.21. Now, the informational note's just kind of gearing us towards the directories for electrical construction and materials, and it's published by qualified testing laboratories. And many listed installation restrictions necessary to maintain the fire-resistant ratings, and all that's done by the engineer who's designing it and providing it to the building official. Building codes itself, like the IBC, International Building Code, has a lot of restrictions on membrane penetrations and having to do with receptacles on opposite walls in order to, the separation, like minimum of 24-inch minimum horizontal separation. All of those type of things for boxes where you have the opposite sides of the wall. And if these are rated walls, then you have to maintain a distance and possibly come up with some other concept where you actually put a block between them, or wood, 2x4 block, or whatever the wall material is, in order to maintain that separation. And of course, the building code. So if you're in that area of the world, then you need to make sure that you're also syncing this up with your international building code. Now, I'm an electrician. I've been an electrician for 30 years. And I started back in about 86, working with my family in our family electrical business, working with my brother, and slowly and became a master electrician in the late 80s. And ever since then, I'm more concerned with the type of wiring methods that I use for these locations, and I'm probably more driven, since we're dealing with fire-rated assemblies and what have you. I'm thinking of a commercial aspect. So a lot of these are always engineered drawings, and we just simply maintain and follow the engineer's directives when it comes to doing this. But I also have to remember that sometimes I might have to come in on the fly and on a job as an electrician, and I might have to do something. I need to understand if there's a ratings of walls, different applications for different types of ducts that are not all the same. That I need to know that I'm going to maintain the rating of that assembly. And that's the key thing. The last thing I want to do is penetrate a 2-hour wall, a fire-rated wall, and now have reduced the rating of that wall. The number of penetrations that are in that wall are going to greatly affect the rating of that wall. So that's all in the building code. If you're into that world, you go to the building code. So that's 300.21. Really, we're just trying to keep the spread of fire and the products of combustion, the soot, the smoke, the carbon monoxide, and all these different things can be a product of combustion. All right, so let's go on down. So we're gearing on today is 300.22, and this is the wiring in ducts not used for air handling, fabricated ducts for environmental air, and other spaces for environmental air, pseudo a plenum, if you will. Before I should start all this stuff, I should probably give you lay the groundwork here for what a plenum is and what it's not. And you'll kind of see where we talk here, because I get a lot of people ask this. So I'm going to have to allow you, because I don't have graphics here. Obviously, this is a podcast. So use your imagination. So let's say that we have a suspended ceiling or a dropped ceiling. I'm sure you've all seen this with the drop-in tiles, and you have this hollow space above it. If I have an air handling unit up there, and I've got a supply and a return going down to this room, let's say the room that you're sitting in now, listening to this podcast, of course, unless you're driving in the car. So this imaginary room you're sitting in, if I'm pulling the air out of the room, up into a ducted system, up into the air handling unit, and then I'm returning it back to the room through another ducted system, through a grate in the ceiling, and so it's all kind of a closed system. But it is pulling air from the room, but once it gets up into the system, it's all closed. So what you have at that point is you have a duct assembly, and those are considered plenums. The air handling space, or the air that moves through there, is also considered a plenum. So all of that is a kind of a closed system, and I'm keeping it very simplistic for that. Now, if I happen to have one of those systems where I utilize the hollow space that's above the suspended ceiling, in other words, I have a grill on the side of the air handler, and I'm pulling in the air that's from that space, that hollow space, and then the room below has open grates that pull the air up through the open grates into the open space above that suspended or dropped ceiling, and then it gets pulled through a filter into the actual air handling unit. Then what I've got is an environmental airspace, but it's acting as if it's a plenum because it is part of the environmental air circulation. But it's not a plenum in the sense of what we know as a plenum, whereas it actually is contained within the ductwork or type of ducted system. Okay? And that's very basically simplistic, so hopefully you get that, or you can visualize that. So if somebody says, can I use, and we'll look at it in a minute, they'll say, can I use interlocked MC? This is a standard MC under UL 1569. Incidentally, there's 3 types. There's corrugated, there's smooth, and there's interlocked. Now, the interlocked is probably the most widely used. It's mass produced. In fact, many people know I work for Encore Wire, and it's a challenge for us to actually keep up with the amount of wire that we have to make with the MC product, because it just sells so quickly. We do a really good job on MC, so that's probably why, because we have this unique smart color ID thing kicking. So you could tell what it is by a glance, and that's without learning any color system. So that's pretty cool. But people ask us, can I put MC cable above that ceiling, which is used as environmental air? In other words, not the one where you have both ends of a duct. If that's the case, then it is considered environmental airspace. It is a pseudo plenum. It's acting like a plenum, but it's not really a plenum, so we don't have the same restrictions. So MC cable of the interlocked type can go up in that location. So people ask me, does that mean that MC cable, the standard type, is plenum rated? No, that doesn't mean that at all. It means that basically, if you look at the code, 300.22c is basically going to tell me that it's an environmental airspace, pseudo used as a plenum, and it strictly tells me in there that I can have MC cable up there. Now, it's not restricting me to smooth or corrugated like you would get in a 300.22b, and we'll look at that in a second. It just says MC cable, so that allows any of the types of MC cable to be used in that environment. Again, very common to use standard interlocked MC cable above a suspended ceiling. No harm, no foul. Not going to be a problem at all. All right, so that was kind of an example of what the space is. Now, can plenums be extremely huge? Yes. I have actually seen plenums that were big enough to walk in. And if that's the case, you have other restrictive requirements that you have to do. But again, if you break it down in the most simplest of terms, that is a plenum. So I couldn't have like an interlocked MC cable in there, but I could have corrugated or smooth in there. Of course, then you have luminaires in there. There's an allowance for luminaires as well under that application that you would deal in. So, and I believe that that would be under 300.22c3, for example, for electrical equipment and all that in there. But we're talking about the wiring methods. So you have to know what you're dealing with. And the good news is most of us deal with, look, it's a suspended ceiling in a commercial application. Yes, interlocked MC can go there. Yes, corrugated or smooth can go there. And there's other types that go. But you can't have PVC jacketed MC up there in that location. Okay, so it is a little bit special. Okay, so that's what you got to remember. We can't have a non-metallic application in there unless, of course, the non-metallic material like a Cat 6 or Data or whatever is actually plenum rated, and then it can be up in there. Okay, all right, so that's why it kind of mimics a plenum, but it's really more an environmental airspace. But it doesn't change the fact that interlocked MC is not plenum rated. It's just rated to be in that environment, and by virtue of what it says in 300.22c. All right, so let's look at the code real quick. So 300.22, it says, wiring in ducts not used for air handling, fabricated ducts for environmental air, and other spaces for environmental air, in parentheses, plenums. It says the provisions of this section shall apply to the installation and uses of electrical wiring and equipment in ducts used for dust, loose stock, or vapor removal, ducts specifically fabricated for environmental air, and other spaces used for environmental air. So we have the 3 different times we're going to deal with. We're going to talk about ducts that are used to remove dust, stock, vapor removal, dust, all that kind of thing. We're talking about those type of ducts. Then we're going to talk about ducts that are specifically fabricated for environmental air. And that could be either fabricated on site, or fabricated off-site and brought to the location. That could be all of those fiberboard ducts, sheet metal ducts, or whatever that get put together on the job site. You see those ducts that are running. Some of those real fancy high-end restaurants, you go and you look up and you see that all of their ducted system is this big tubes. All of that are ducts that are specifically fabricated for the movement, exchange, circulation of environmental air. Okay, so it's kind of like a closed system, if you will. There's an entry, supply, and there's a return. All of these type of things. All right, so let's look at A. It says ducts for dust, loose stock, or vapor removal. Okay, so these are the ducts that do that. And it says no wiring system of any type shall be installed in ducts used to transport dust, loose stock. And when we say dust and loose stock, we're talking about things like, most common would probably wood shops, furniture shops that has those duct systems that remove all this dust and loose stock from the cutting process. Or flammable vapors. You could have a duct system that takes an area and changes maybe the different class from a class 1 division 1 to a class 1 division 2 or whatever it would be by the removal of certain types of vapors, things like that. Obviously you can't penetrate those and run any wiring method in there. It also says no wiring system of any type shall be installed in any duct or shaft containing only such ducts used for vapor removal or for ventilation of commercial type cooking equipment. Okay, so no wiring in there. Now we do have some allowances for certain types of lighting, if it meets the caveats that we talked about in a second, to go inside of, let's say, a commercial cooking hood. But not inside of the commercial cooking duct system itself. But if you get a commercial cooking system with a luminaire in it, for example, this is all part of the listing and it's been evaluated. So don't redig the wheels on that. So that's just kind of something to be. So we're not looking to put any wiring method inside of ducts that are used for dust, loose stock, or vapor removal. Obviously, we don't know what could happen. Obviously, the loose stock and the dust moving real fastly and all that could act like sandpaper and eventually damage the wire that's in there. And of course, the vapor could cause it to chemically change and deteriorate and have a problem. And of course, loose stock could chip it, and cause it to rip and things like that. So you don't want any. That's a common sense one, right? Next one, let's talk about 300.22b, ducts specifically fabricated for environmental air. Again, we talked about what those ducts are. And they're kind of a closed type of system. In other words, if you're looking at a room, you have an air handler in the ceiling, you have a duct that comes out one way to the return, and one comes out to the supply, and it's pulling in and blowing out, okay? And it's all within a closed system. Okay, then that was been specifically fabricated for that application, okay? We are not talking about sucking the air from the room up and through grates into an open ceiling above a suspended ceiling. That would be environmental air. That wouldn't be a totally specifically fabricated duct system. Now it says equipment, devices, and the wiring methods specified in this section shall be permitted within such ducts only, if necessary, for the direct action upon or sensing of the contained air. Okay, so even these ones that are specifically fabricated, I cannot put equipment, devices, or even wire methods in them unless they have some type of function. Direct action upon that air or sensing that air or some kind of damper or something that I need to put in that fabricated duct, then I'm going to have the allowance to do that. Now, I'm going to be caveated with the type of wiring methods that I can use, but I'm going to be given some leeway here. Now, it says, where equipment or devices are installed and illumination is necessary to facilitate maintenance and repair, enclosed gasketed type luminaires shall be permitted. Oh, so this one is a good example where I might have a very huge specialty fabricated duct system. In fact, I've seen some that might be as big as a room for a big manufacturing facility where you actually walk into this ducted system, and it's specifically fabricated duct system with all these returns and supplies and everything, and in there you might have luminaires and whatnot, and they have to be specially made to go in there, the gasketed type for this type of environment. Okay, so If you have to get in there for maintenance and repair, then what you get is an enclosed gasketed type luminaire, and you buy those and they'll tell you they're enclosed and they're gasketed type and they're heavy duty and they go in there as well. Now, let's talk about the wiring methods that could be in, that you could actually penetrate these specifically fabricated ducts if you had to have something that had to do with the direct action upon the duct itself, or the sensing, or the airflow changer, or whatever, diverters, or whatever it is you have in there. And it says, only wiring methods consisting of type NI cable without an overall non-metallic covering, and nobody works with MI anymore, I'm just saying. Type MC cable employing a smooth or corrugated impervious metal sheathing without any overall non-metallic covering. So again, if you can penetrate it and it's for the sensing, you can use smooth or corrugated MC, but not the interlocked. It also allows electrical metallic tubing, that's EMT, flexible metal tubing, FMT, intermediate metal conduit, IMC, or rigid metal conduit without an overall non-metallic covering shall be installed in ducts specifically fabricated to transport environmental air. That's what it's for. Okay. Floodable. If you're going to use flexible metal conduit, because it does allow flexible metal tubing, it does allow flexible metal conduit with the shall be permitted, but the length is not to exceed 4 feet. Okay, so you can use FMC, not just FMT, but FMC, but you're going to be limited to 4 feet. So really, you are only penetrating to get to that sensor or whatever's in there, maybe the diverter or whatever it is, the flapper or whatever it is. I'm not a duct guy or HVAC guy, so whatever you got. If there's something to get in there, or maybe it's for a smoke detector for the flow sensor, or something like that that's got to be in there, then okay, you do have the penetration, but you have to keep it to the distance. Now, it's the FMC that's limited to 4 feet, okay? Now, it says to connect physical adjustable equipment and devices permitted to be in these fabricated ducts, okay? So, read it again. Flexible metal conduit shall be permitted in lengths not to exceed 4 feet to connect physically adjustable equipment and devices permitted to be in these fabricated ducts. Again, like maybe a smoke detector or whatever. It says the connectors shall be used with flexible metal conduit shall effectively close any openings in the connection. Okay, so you have to make sure that if you're going to go in there with the FMC, that you actually effectively close any openings with the connection itself as part of the installation. Now, there are some exceptions that came about in 2017 code, so we'll look at them here. And let me blow it up so I can see it. Exceptions. Wiring methods and cabling systems listed for use in other spaces used for environmental air, plenums, shall be permitted to be installed in ducts specifically fabricated for environmental air handling purposes under the following conditions. So this is important because this is new for 2017. Number one, it says wiring methods or cable systems shall be permitted only if necessary to connect to equipment or devices associated with the direct action upon or sensing of the contained air. Kind of the same thing. So the allowance here is to say, okay, we gave you a list of MC of the corrugated or smooth. We gave you which didn't give a length, really. We gave you the ability for the MI cable. We gave you the ability to use EMT, FMT, FMC with a limited to 4 feet. And we gave you a rigid metal conduit. We gave you all these lengths here. And with flexible metal conduit, we gave you the 4 foot maximum, and we gave you the caveat to make sure that you effectively close the opening of the connection. But now it's telling me that, look, the exception to this is saying, look, now, wiring methods and cable systems listed for use in other spaces used for environmental air, like a normal traditional MC, shall be permitted to be installed in ducts specifically fabricated for environmental air handling under the following conditions. We just read the first one. The wiring methods or cable systems shall be permitted only if it's necessary to connect to equipment or devices associated with the direct action. And then 2, in total length of such wire method or cable system shall not exceed 4 feet. So we're basically throwing on and allowing it to be done like FMC, without the caveat about the effectively closing the opening end of the connection if you want to use something like an MC. Now, when I bring up those ones here that says, well, what are you talking about? These listed for use in other spaces used as environmental air. What are you talking about? Okay, now we're going to get into 300.22c. And we're going to talk about those. So what is 300.22c? Now 300.22c says other spaces used for environmental air, plenum, for example. I like to say a pseudo plenum. It says this section shall apply to spaces not specifically fabricated for environmental air handling purposes, but used for air handling purposes as a plenum. Okay, so it's being used as a plenum. It says this section shall not apply to habitable rooms or areas of buildings, the prime purpose of which is not air handling. Okay, so we're trying to say, look, don't get this confused with other habitable rooms in a building or other areas of the building that not specifically has a purpose for air handling, because you can use all the other wiring methods in Chapter 3 in those areas. Okay, so don't want to confuse it with this saying you can only use this type of area in any area that might have other spaces used for environmental air, and oops, you're going to only be limited to what's in here. No, that's not what it's trying to say. We want to make sure we're specifically speaking about those other spaces that are used for environmental air. Kind of the example would be that, the space above a hung ceiling. That would be a great example of environmental air handling space. And it is an example of a type of other space that is used, and that is a space that's directly what we're trying to target here in 300.22c. That's what we're trying to target, that exact space. Now, if you really want more detail on what other space is used for environmental air is, then a good resource would be to go to NFPA 70A. And that would be in the 2015 edition. And incidentally, the National Electrical Code gives you informational notes, and that's the thing I love about the informational notes, which used to be fine print notes, a couple cycles ago changed to informational notes. They're great roadmaps throughout the NEC. They give you good direction on where you might need to go to get some additional information. And so, for all of you that want a more in-depth understanding of what a plenum is, you simply would go to NFPA 70A. And it says here in the informational note, it says the phrase other spaces used for environmental air, and it has parentheses, in the parentheses it's got plenum. And it says, as used in this section correlates with the use of the term plenum in NFPA 90A 2015 edition. And that document is titled Standard for Installation of Air Conditioning and Ventilation Systems. And other mechanical codes where the plenum is used for return air purposes, as well as some other air handling spaces. So it covers a lot of information in NFPA 90.A. At the beginning of this podcast, I kind of gave you a 30,000-foot view of what we were talking about for our everyday use. Now, there is an exception to this rule. It says this section shall not apply to the joist or stud spaces, and that's stud spaces, of dwelling units where the wiring passes through such spaces perpendicular to the long dimension of the space. So if you have two 2x4s running and you have a cavity in your space and you got them running 10 feet, and then you kind of come perpendicular to it, in other words, you drill it and you have to penetrate and you have to go through it, in dwelling units, that's okay. None of these wiring methods are going to kick in here. The exception to this says, okay, that space is being used possibly as probably return air, and since it's a dwelling unit and you're using that space which the International Residential Code permits, and as long as I go perpendicular to it, then I'm okay. All right, I go perpendicular to the long dimension, then I'm not going to be a problem. So this doesn't apply to have to meet the requirements of the wiring methods that are here. So typically, that would be a non-metallic sheath cable in a house if you're going to use that cavity for like return air. Okay, I wouldn't use it for supply air, and I don't know if them HVAC standards would prohibit that, but I know that many people use the studded cavity for return air all the time. All right, so if you penetrate it with something, then running a piece of non-metallic sheath cable through it perpendicular to the long dimension is not going to really affect anything. Okay, you don't want to run it parallel with it because then that would be prohibited. You don't want to run perpendicular. All right, now let's talk about the wiring methods, getting back on track with the other spaces used for environmental air as defined in NFPA 90A. It says, number 1, it says wiring methods. The wiring methods for such other spaces shall be limited to totally enclosed, non-ventilated, insulated busways having no provision for plug-in connections, type MI cables without an overall non-metallic covering, so I can have MI in there as long as I have no non-metallic covering or PVC jacketing on it or anything like that. Type MC cable without an overall non-metallic covering, so that is perfectly acceptable in these other spaces used for environmental air. Now notice it just says type MC cable, so the most restrictive of all, which is the interlocked type, is perfectly fine, but also you could run smooth or corrugated in there if you want, but I don't know why you would. Typical in this type of application above a suspended ceiling or a dropped hung ceiling, you just typically would see normal interlocked MC cable. Type AC cable is allowed to be up there, or other factory assembled multi-conductor control or power cable that is specifically listed for use within an air handling space. So you want to use some kind of cord, a power cord or control cable or power cable, that type of thing. We're not talking about extension cords. We're not talking about all those type of things up there. We're talking about power cords that are evaluated for use in environmental airspace, control cords that are evaluated for use and they'll be marked as such. All of those type of things can go above that space. And of course, we're also talking about, you could obviously run plenum rated Cat 5, Cat 5Es, Cat 6, or what have you. Cat 6A, I think, is the newest one coming out. Those type of wires up there, as long as they're plenum rated and what have you, you can install them. Those non-metallic type products up there. Okay, but they do have to be rated for that environment. Now, it also goes on to say, or listed prefabricated cable assemblies, kind of ones I just finished talking about, of, not like the ones I just talked about. These are listed prefabricated cable assemblies of metallic manufactured wiring systems without non-metallic sheathing. That's like the relocks. It goes on to say, other types of cables, conductors, and raceways shall be permitted to be installed in electrical metallic tubing, flexible metal tubing, intermediate metal conduit, rigid metal conduit without an overall non-metallic covering, flexible metal conduit, or where accessible, surface metal raceways or metal wireways with metal covers. Now you'll notice that there's no length limitation on here, even with the FMC. Okay, this is an application where you really, it's up in a space that's going to have an awful lot of things up in there. Okay, the ducts pulling air from it and everything. It's not the same as the closed system where you have the fabricated duct. Although the change for 17 is going to allow these methods to actually penetrate those fabricated ducts, but only if it's for the action of something directly within that duct itself. Okay. All right, so that means I can run EMT up there and pull regular conductors inside of the EMT. I get a lot of questions that. They ask me, what, do y'all sell XHHW or THHW that's designed for a plenum? And I go, you know what? You don't do it that way. You use the wiring method for that location. The conductors within it don't have to be anything special for that application. All right, and it keeps on. Now, it also says this. Now, this is something that came in last cycle. It says non-metallic cable ties and other non-metallic cable accessories used to secure or support cables shall be listed as having low smoke and heat release properties. So you can't just use your standard run-of-the-mill cable ties. You have to make sure that those cables, and I don't know, I'm sure the cheap ones you might buy from, let's say, a Harbor Freight, and I'm not going to just say that's because everything's cheap at Harbor Freight, because I got a lot of stuff I get from Harbor Freight. I'm using that as an example. You might be able to get some really, really bulk, cheap tie wraps, but it doesn't necessarily mean that they're rated to be in a space like this above a suspended ceiling in order to secure all those cables and everything. Okay? So that's something to keep in mind. And if you didn't know what low smoke or low heat release properties are, or heat release properties, then what you want to do is the informational note kind of gives you some direction to ANSI UL 2043, and it talks about the optical density of 0.50 or less, which is what we have to get done on our FPLP type of cable to use for like fire alarm systems and whatnot that can go in a plenum space, and that ends up getting evaluated under NFPA 262 as well. But anyway, and you have what's called an average optical density of 0.15 or less, and a peak heat release rate of 100. Let's see here, kilowatts or less, tested in accordance with the NEC UL 2043 standard. You know what? I'm not an expert on those standards. I don't really know a lot about 2043, but I'm just saying, when you buy your tie wraps, electricians, just if you're going to use them above a suspended ceiling, make sure they have on there something about low smoke and heat release properties. Obviously, cable trays can go above a suspended this type of location as well, because as long as you meet provisions of A and B, it says cable trays, which we are in 300.22C2. It says the provisions in A or B, notice there's an or there, shall apply for the use of metallic cable tray systems in other spaces used for environmental air. We're accessible as followed. Again, we're accessible, not closed up in a ceiling. We're accessible. A lets me use a metal cable tray system. And it says the metal cable tray system shall be permitted to support the wiring methods in 300.22C1. And that was the ones we just talked about, the regular MC, all these other type of things. So you can have that one there. Then it has also B. It says A or B. B is a solid bottom and a solid side and bottom metal cable tray system. Now it's a solid bottom and solid side and solid bottom metal cable tray system with a solid metal cover shall be permitted to enclose wiring methods and cables not already covered in 300.22C1 in accordance with 392.10A and B. Okay, so you can have a solid side and bottom metal cable tray system, and it also has solid metal covers. So basically, and I know somebody's going to say something about it. Basically, it is a cable tray, but it kind of acts like a gutter, if you will. But it's solid on the bottom, solid on the sides. It has a cover on the top that you screw down, and it seals it up that way. Basically, that's what allow you other wiring methods and cables that are not already covered in 300.22C1. So that does expand your capabilities if you want to use that type of cable tray system. And of course, you end up with item 3, which is equipment. It says electrical equipment with a metal enclosure or electrical equipment with a non-metallic enclosure listed for use within an air handling space and having low smoke and heat release properties. Here we go with that again. And associated wiring methods suitable for the ambient temperature shall be permitted to be installed in such other spaces unless prohibited elsewhere in the code. Okay. And then, of course, we do give you an informational note again. It talks about that optical density and the average optical density and peak heat release rate and all this kind of good stuff. There is an exception. The exception to the rule says integral fan systems shall be permitted where specifically identified for use within an air handling space. So obviously, if you have the fan that's integrated, look, if you buy the air handling system and you buy this air handling space, chances are the integrated fan is going to be rated for that anyway. As an inspector, I don't think I'm going to dig inside that equipment if this has all come as a completed unit and what have you. All right? And then lastly, let's talk about 300.22D, which is information technology equipment, and that's covered in Article 645. But it goes on to say electrical wiring and air handling spaces beneath a raised floor for informational tech equipment shall be permitted in accordance with Article 645. Okay? Now, in 645, which is not about this podcast, but we have a podcast that we talk about 645 and whether or not that space underneath the raised floor is actually considered environmental air or if it's just circulation. And there is a big difference in the two, whether it's connecting multiple rooms or it's all self-contained ventilation type of system, and whether or not it's considered air handling area beneath that raised floor. Okay? But just so you know, electrical wiring in air handling spaces beneath the raised floor shall be permitted in accordance with 645. And so 645 has its own rules that you have to be aware of in there. All right. Well, you know what? I don't know how long that one went on, but kind of covered everything there for dealing with it. So hopefully you got something out of that. I want to thank y'all for listening to the podcast today in this episode. It's exciting to see the different stuff that we got coming up for 2018. But again, we kind of just went over 300.22, 300.21. Maybe you're in that long 2-hour ride somewhere and you just had to listen to a podcast on that. So summary, can interlocked MC cable go in an environmental airspace above a suspended ceiling? Sure. Does it necessarily mean that interlocked MC cable is plenum rated? No. It means it is rated to go in that environment based on 300.22c. 1, so that's not a problem. Now, also, can I penetrate a fabricated duct if I need to get to a sensor or whatnot? Sure, I can with an interlocked MC cable now, as long as I don't exceed 4 feet. If it is a fabricated duct, I really can't penetrate it anyway unless I use one of the wiring methods, and it has to also be limited for that sensing unit or something that has a direct control of that ducted system or monitoring the air inside or what have you. I can't have any wiring method within a duct that's used for removal of dust or loose material, flying things like in a wood chipping or wood production plant called loose stock type of thing, or vapor removal. I can't have any wiring methods in that type of application. So those are kind of your 3 type of ducted systems. So if you went to a location and everything had ducts, so it's not using the space above the ceiling or whatever, or it's a finished ceiling. Keep in mind, you're generally never going to use the open space above a ceiling if it's all sheetrocked or gypsum board. Okay, this usually only utilizes it when there is a suspended ceiling with replaceable or removable tiles and things like that. Okay, that doesn't mean you never might run into something. There are some type of ceiling systems that you can remove tiles and whatnot, but that's just the general concept, and I like to keep it general. If everything's enclosed in ducts, then that is specifically fabricated, whether it was on site or bought to the site or fabricated off site. It doesn't matter. They're specifically fabricated. If you're using the environmental airspace or the space above a suspended ceiling or something like that, then that's pulling it from the environment up into the space into a unit. Then that is environmental airspace being used as a plenum. And then you have all of the wiring methods that are allowed in 300.22c1. And of course, we covered cable trays. If you follow the cable trays in 300.22c2b, solid side and bottom with a cover on it, then you can expand your wiring methods that can go in there. So if you just use a regular metal cable tray system, then you can put all of the wiring methods that are 300.22c1 inside of that if you want to do that, and it will support. Remember, cable trays are not raceways, they're a supporting system. All right. You still have to secure, and you're supporting it with the cable tray system, but you still got to secure your wiring methods that are inside that tray. I think a lot of people think you just dump them in there and you don't have to do anything with them. No, still got to secure them. Still got to meet the requirements within the respective article of that wiring method. Anyway, enough of that podcast for the day. Thanks everybody for tuning in to this podcast. God bless until next time. Stay safe out there, and hopefully you all will have a wonderful and blessed holiday season.